All right, so today we are going to start Unit 3, Module 1, Lesson 3, arrays. I know, I love saying that. Arrays are a method of storage. There are several ways of storing information. Most of them start with an array and build up something larger based upon that array structure. So array is kind of like the fundamental base level of everything. And if you understand arrays, it goes a long way to understanding how everything else works. So, arrays are an object. Okay, that's the most important thing that you have to learn. It's an object, it's a thing, which means when we construct an array, it's going to get a memory address that points to a location that has all the information stored at. When we construct an array, we have to do a little bit more than we used to have to do with strings. With strings, all we really have to do is tell the string what value it's going to be stored in it. In arrays, we have to do more than that. There's a couple basic setups that have to be done to make the array work. So let's find out what is an array and what actually do we have to do to set one up. So it holds data. It has methods. And it's not a primitive. The way it holds data is much like a table. And that's not a bad analogy. Think of an array, a simple array, as a single column table, where each row or cell of that table stores a piece of information. And the name of the array, the variable, is like the header of that column. Now, right away, your mind might be going, oh, he said table, and you kind of think of multiple rows and multiple columns. That's more complicated arrays. We're only talking about a single column to start. All the items that are in that column must be of the same data type. So if you're going to store integers, a column of integers, everything must be integers. You can't do a double and then an int and then another double. That won't work. So if you need a double, then everything has to be doubles. If you're going to do strings, everything has to be strings. If you're going to do scanners, they would all have to be scanners. Clearly, arrays can hold primitive types, because I just listed those. But it can also hold object types. So it can hold strings. It could hold, get ready, other arrays. Yeah. You can do an array of arrays, which is how we will end up building a row column table, right? Where it has rows and columns. It's an array of arrays. You can go even further and do an array of 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 forever. You have no constraint for that. You have no way of visualizing what that means right this second, but I will absolutely let you know how to visualize multi-dimensional arrays, and that's what they're called. Arrays within arrays are multi-dimensional arrays. Right now, we're looking at a single dimension array, one column. And in each cell of that column, we are holding one object, or one primitive. And everything in that column must be of the same type. So all ints, all doubles, all strings. In order to design an array, we have to tell Java that it's an array. We have to tell Java the type that we're going to use, and we have to tell Java the name of the array we would like to use. So these first three commands declare the array. They don't store anything in it yet, but they declare the array. So it's going to be an array of integers. I know it's an array because I put these brackets here. Rather than using a word and say this is an array, the programmers of Java could have said int array and put that there. Instead, they used the brackets. So it's a symbol to declare an array, not a word. So the second part of this is the constructor command. We use the word new. That tells Java to actually construct the array. We have to tell it it's going to be constructed of ints. And we have to tell it the size of the array. How many blocks in memory am I going to make available for this array? I have to dimension it. So there's 7 blocks. They're indexed starting at 0 through 6, which gives us 7 spots, 0 through 6, much like the strings. In fact, you could really think of a string as an array of characters. It's a fundamental structure. Strings technically are stored as arrays of characters. You don't need to worry about that because Java does all that for you, but that's really what Java's doing. It's storing an array of characters. So a lot of the things that we did with string operators, we could do very similar things with arrays. You know, we can loop through them. Just like you loop through strings, you loop through arrays almost identically. You can jump to a particular part in an array. Rather than having to use character at, you can just go to the exact index using the name of the array and the value that you want to look at. So we'll look at how to do those different things. Some people ask, why does Java declare int twice? Right? That would seem silly. Why not put something, why put this here at all? Why not just say int bracket, instead of saying int bracket list, why not just say bracket list? Well, because technically what's happening here is it's a declaration and a construction. Really, it's 2 commands. We could separate this into 2 separate lines. We could say int bracket list semicolon and leave that alone. Then later go back and say list equals new int 7. They're separate things. We just happen to typically do them in one line. So it may look like we're repeating ourselves and saying it twice, but technically we are doing 2 things in one line of code. We are declaring the array and constructing it. In Java, all constructors have to have the same name as the class. In Java, all constructors have to have the same name as the class. Thus, when we did string and declared a string, the formal version of it is string, my string equals new string. The name of the class and the name of the constructor happen to be the same thing because Java makes it that way. So this is the type. This is the name of the constructor. They're the same. So we're not repeating ourselves. We're really doing 2 different things that happen to have the same name. It's designed on purpose that way. Again, you could ask yourself the question, why would they do that? Well, I think it's a matter of convenience. It's easy to remember. If you have an object called string, it'd be nice for you to know the constructor. Oh wait, let's make it the same name. You don't really have to know 2 things, you only need to know 1 thing. The name of the class happens to be the name of the constructor. Could they have designed it differently? Sure, but then it wouldn't have been Java, it would have been some other language. Not every language functions in this way. So this is a Java command. It creates a new reference. Java sets up in memory and constructs everything. It puts all the pieces together that are needed to build this object. That's what the new command does. It's the actual builder. So whenever you see the new command, something is being built. An object has been created. We use this with the scanner class. We absolutely did a constructor with the scanner class and built something. In fact, some of you sometimes found that you had to build more than one scanner in order to get it to work the way you wanted it to work. String is one of the examples of a class that doesn't necessarily use it. We talked about this before, but there are two ways actually to declare a string. I could say string, I'm just going to make it simple, x equals to hello. This is the Java short version of declaring a string. But really, what's going on here is as soon as Java starts to see that this is a string, it knows that we're actually doing this. This is the long version. This works. Here we are using the new constructor, and we are constructing a new string. And we're getting all those methods and all those things that we talked about the other day. All that's coming with this new object. It's being put together in a nice little package for us to use. All built. This kind of makes it seem like not much is happening. But the designers of Java know that we use strings so often that they were cutting down on keystrokes and decided to just eliminate the new constructor. They also did one extra thing, which is that if you design a string this way and happen to have another string that is identical, in order to save memory, it has an allocation table that keeps track of all the string literals and just points to that string literal that has already been created. It saves on memory. So that's the other reason why they do it. It's a memory issue. So again, Java was designed for programmers and engineers. It was not designed for students. That's why there's some of these weird things that are complicated to understand. It wasn't made to be taught. It was made for engineers to do something with. Engineers and designers said, hey, we need a computer language to do X, Y, and Z. Let's write one. And they sat down and they wrote a language to accomplish what they needed to accomplish. They didn't write a language that was designed for everyone to be easy to learn. So there are some of these odd things that are put in here for specific reasons. Specific solutions to problems that you have not seen yet. But that's why these things are in here. Mostly memory is why this is set up. Okay. I can get control. Couple vocabulary words that are really important. Element, it's the individual cell. An element in an array is the individual cell of the array. The index is the counter of the array. If we have an array that is of size 7, it is indexed 0 through 6. It is 1 less than the length. The index is always going to be 1 less than the length. You have to be careful when traversing through an array to make sure you don't accidentally step off the edge. Because if you step off the edge, we're going to get an error. Array out of bounds. It's not a compiler error, it's a runtime error, because you can't step off the edge until you start walking through it. So the computer won't analyze your code and say, whoa, whoa, you're going to go off the edge here. Nope, it'll just let you try to go off the edge, and when you do, it'll say there's an error. So it's a runtime error, not a compiler error. And then finally, initialize. We haven't initialized any arrays yet. We declared them, we constructed them. Initialize occurs when we actually store information in those boxes. Arrays need to be initialized just like any other variable before they can be used. You have to put data in them before you can really do anything with them. So we're going to store values in those arrays. So when we construct our new list here, the other way of constructing it, notice this is a little different. The brackets are on the other side. The name comes first. Why? Because they can. They made it so you could put the brackets either before the variable name or after the variable name. It still works. It doesn't make a difference. So you could do int bracket list or int list bracket. Both work just fine. No difference. Again, it was because they decided sometimes people switch them, so let's make it easy, make both work. But the new int, that has to always be the same. This is what gets set up in memory. We have 7 boxes, 0 through 6. Why did we do that way? Well, they just decided to start counting at 0. Just like they did everything else. They're being consistent. That's Java. Not every language does that. Most languages do that, but not every language does that. So you'd have to know it's language specific. So we go to the length minus 1 if we want to get to the last box. It's the length minus 1, which will be important for us in code. When we're trying to traverse the array, we have to know that we're going to traverse all the way through the length minus 1. Now, how do we get to the length? Well, the length is a property. It's a piece of data, right? It's information. It doesn't have to do anything to know its length. There's no action. So in order to get a length of an array, you would do the name of the array, in this case list, dot length. Notice, no parentheses. For strings, we had to put parentheses because it actually had to go through and count them. Arrays have to know their length. Therefore, there's no parentheses. It's not a method. It's data. So when we're doing an array, dot length is just data. It's not counting anything. It always knows its length. That gets set up in the constructor. You set it up in the constructor when you put this 7 here in these brackets. It knows its length. It gets stored as data. So here's some examples on using arrays once you have the information in there. I can treat it like any other variable name and associate any operation I want and affect a particular box just by indexing that box within the brackets. So for example, if I wanted to increment the indexed value number 4, which would be the 5th box, so that would be this number 9, I could increment it by just doing the name of the array, the box I want to target in brackets, and then do whatever command I want, plus plus. Here I'm going to say that the box indexed at 0 is going to be set equal to the box indexed at 1 plus 2. So what happens is we do negative 10 plus 2, which gives us negative 8, and then we're going to put it in box 0. So swap out the 14 and make it a negative 8. So now it becomes a negative 8. This says take the value that's in box indexed at box 6, which is the 3. You're going to add 4 to that, excuse me, times by 4. So 3 times 4 is 12, and then put it back in the same box. So all the variable operations that we dealt with before are all fine. It's just now we're indexing a particular box of the array as opposed to indexing just one thing. If I do system.out.print list, and I don't print out a particular value of the array, Java will not print out a pretty version of the entire contents of the array. It will not do that. It will actually print out some variable information. It'll print out some memory information. It will not print out the contents of the array at all. Because as far as Java is concerned, you're asking about the object list. You're not asking about the contents of list. You're asking them to print the object. Well, when you print the object, you're printing information about the object, not the contents of. Other languages like Python, if you say print list and you're printing an array, it is designed to nicely print all the contents of the array. So if I want to print the contents of an array in Java, I need to go through the array box by box and print out the contents of the box. So if I wanted to print this out, I'd have to say list 0. I'd have to print that. Then I have to print list 1. Then I have to print list 2. I have to print list 3, list 4. If only I had some type of structure that would allow me to step through something in sequential order for a specific number of times. 80 loops ago. I know, really corny. But yeah, that's why one of the reasons why we use for loops. That is a major use of for loops, is stepping through arrays. So you use a for loop and go through that array. You know the length, so your index would be stopped at just before the length. So it'd be I less than length. And you'd go by 1 each time, and you'd start at 0 and go through that loop. The other way of storing an array, it's a shortcut, built-in shortcut, is to populate it immediately. And the way we populate it immediately is, rather than doing new int 7, we take the curly Q brackets and we put a series of numbers in those curly Q brackets, or a series of anything. It could be strings, anything we want. And we set it equal to the declaration. So int bracket list. Notice this time I put the brackets on the other side. I'm just trying to show you that they can go either way. And I put in my curly brackets, and Java knows how to count. So when it does this as part of the construction process, it will count. It's like when we did the string literal and stored it in string. It's a shortcut built in. They thought it'd be nice if they could build this shortcut in, a short, quick way of storing a whole bunch of values in an array without having to go through individual blocks. So they built in a shortcut. Why? Because they found it useful. So rather than doing this, list 0 equals 14, list 1 equals -1, list 2 equals 1, every single block, what they decided to do is just make some way of storing them all in one shot. So we could set up an array all at once. Very useful. All right, so I think we're going to hold this off to the next lesson. We're going to talk about our multidimensional arrays in the next lesson. But I want you to start thinking about it. How would you represent a two-dimensional array? That's kind of obvious, right? Table. Three-dimensional array. Again, not that bad. A cube. 4 dimensions. Uh-oh. 5, 6, 30. How does that get represented? What does that mean? Right? A two-dimensional table makes sense. A three-dimensional block where each cube, like a Rubik's Cube kind of thing, each one has a location. But how do you go beyond that? You know, how do you represent where that is? So we're going to start talking about that in the next lesson.